Hi, my name is Ji-Hoon Lee, and today I'll be talking about a dedicated on-device AI framework we've been working on, NNTrainer. So let's begin with current status of machine learning. The machine learning has become much prevalent and widely used in applications. So please consider an example, which generates a text from a sequence of voice, and you might want to use this to record speech like this, or a lecture, or whatnot, so that you can have a little database that can be looked up later. There will be a magic box which would turn a sequence of a sound to a sequence of alphabets. When the service was first launched, the developer would have tested a lot, so it's working cool. But as time goes by, you'll get many more complaints from customers. For example, there might be accuracy issues, as the surroundings where the application is executed will be different from users to users. For example, if you're trying to record music lyrics from a studio, we'll have a different characteristics from where you're trying to record a voice of a swimming coach in a swimming pool. Or there might be a performance issue. If some users are running the service on some devices with limited resources, user experience won't be that great. Lastly, there will be desire to use the application for other tasks. Perhaps others who speak different language might want to use the app. Or even more, some others might want to find mood of one's dog. In order to satisfy all the requirements, one magic box, although you can improve the performance, can't solve all the problems. It is because you can't cover all the scenarios from the users. If you're running the service in a wearable device, you might want to sacrifice the accuracy of the model. Or if you're speaking different language, the model has to be trained to match the characteristics of the user data. So, I believe personalization is the key for the next artificial intelligence. There are millions of other applications which use machine learning to provide a good user experience, but could give the best user experience with the personalization. The personalized model will be more accurate because it has been retrained to fit to user data, while some degree of the model compression can be done with the characteristics of the user data. And even, it can adapt to other tasks easily on demand. This personalization can be done with deploying a model and prepare data for training and retrain the model per person per device, which means it'll need lots of computing power and resources. So in order to cope with this situation, one approach would be to personalize model on a server by uploading the gathered user data on the server and conduct training right on the server. But server-side personalization has some issues. It will need network connections and will be exposed to security and privacy concerns, which we have to aware more and more. And finally, perhaps it's too costly to upload each model on the server and train for your purpose. So if we can personalize on device, it will bypass issues from on-server personalization. It won't need any network connection. There will be no privacy issues and no additional operational charges. So it will be relatively free from some restrictions from on-server personalization. The problem we found is that there is no mature open framework we can rely on. And pretty much of the on-device AI solutions are focusing on the inference and not training. So there is limited accelerators supported. Instead of giving up, we decided to contribute to the society by making one and to exploit the existing accelerators for inference on device. So we are introducing NNTrainer. It's a lightweight on-device personalization framework under Apache 2.0. NNTrainer is basically a deep learning framework based on neural network like PyTorch or TensorFlow. So it has a basic features as other frameworks do. We support operation abstractions, which we are calling this as a layer, and backpropagation and model parameter updates through optimizers. Then what makes NNTrainer suited for the on-device? I'll talk about with the example introduced earlier. So in the earlier example, there is a voice coming in from the user dataset, and the magic box which magically turns into a text. If we uncover the magic box a bit, there will be a model that does a series of operations, which we call this as a layers. And we extract characteristics or features, we say, of the incoming data with those layers. And there will be another model which turns the features into a visual desired output. Let's name the first model which outputs feature as backbone, and the latter model which generates a visual output as classifier to tell those two. For example, backbone can be a model like a ResNet or MobileNet, and classifier can be consist of a fully connected layer with softmax. Now, I'll talk about what NNTrainer can do to make the model personalized. NNTrainer can increase the accuracy for the user data, and NNTrainer can make the model faster, and of course, it can adapt to different tasks. First, NNTrainer can fine-tune the whole model with given user data just as other frameworks are able to. But training the whole model is quite heavy, so instead of training the whole model, you might want to train only the part of the model. Also, you can attach a new classifier to transfer knowledge to other tasks. Say, in this case, you can adapt to a different set of language or incremental language models. Another cool feature we have is that we provide a way to reuse existing backbone with conventional frameworks, in case you're not interested in retraining the backbone. We support other frameworks like PyTorch or TensorFlow Lite to be plugged and used instead. Moreover, for some operations, we directly support loading a graph from TF-Lite files, so that you can retrain the model without further boilerplate works of constructing a NNTrainer layers. If you need an operation which we don't support, you don't need to worry. We provide shared object-based plugins, so you can build your own, build it as a separate SO, and plug it without rebuilding whole NNTrainer again. With those basic functionalities, you can construct a trainable model for your needs. For example, you can try attaching multi-heads for boosting up the speed or richer information. Or because the backbone is treated as a layer, you can recursively stack up the backbones to make a more complex model. So for example, a ResNet block can be defined as a backbone layer. Let's summarize what NNTrainer can do. You can make a model more accurate with retrain whole or part of the model, while you can optimize the model for performance by restructuring the model. And the model can be adapted to different tasks by switching the classifiers, or can be used with other conventional frameworks. Up until now, to enable training on device, we were focusing to optimize the memory usage, and we made it possible to save the maximum RSS memory up to 40 times compared to other frameworks while matching the time when running in CPU. The reason we've been focusing on the memory optimization was that for some low power devices, the memory restriction is very harsh. For example, if you have Samsung Galaxy Watch, which has memory of 768 megabytes, you won't be able to train VGG16 model. If you have experience with other frameworks, it'll be intuitive to use NNTrainer. NNTrainer has coherent API sets with Keras APIs. So you can create a model and create a layer, then add it to the model, compile, and train with a single line of code. I'll show a demo with NNTrainer made with Samsung Galaxy Watch. The demonstration simulates turning a handwriting to an emoji. In this demo, the user is asked to draw symbols for some emojis like smile and sad. And then, the model inside it is trained to learn the symbol. Later, the model is evaluated on the fly. In this example, first you feed the data with handwritings for each emojis. After feeding data is done, training undergoes. Lastly, you can run an evaluation, where you draw something and let the model guess. I'll show the moving clip one by one. So when feeding data, you draw sad for the sad face, and drawing smile for the happy face, and draw sad again. After feeding data is done, training happens. Because in this example, I'm training only the classifier, it happens quite fast. Now it's time to evaluate our trained model. Let's see. If you put smile symbol, it outputs smile emoji. If you put sad symbol, it outputs sad emojis. And if you draw something confusing, the model will not very confident about the result. This Handmoji example contains human-readable model descriptions in INI, which contains optimizers and layers and loads as well. In this INI, we define a model section with type neural network, and we also define sections for optimizers, backbones with TF-lite, and classifiers with a single fully connected layer. And after the model description is ready, this demo uses Tizen C API to construct and load model from the INI file, and add dataset and run. Because NNTrainer is on-device framework, we are supporting and planning to support multiple architectures and platforms. We mainly support Tizen official C API with RPM packages, Ubuntu with Debian build, and Android, but it can be built for other platforms at will. Thanks to CI, we are releasing daily build for those. If you are interested in, please visit github.com/nnstreamer/nntrainer and leave some questions here so that we can reach you out. And don't forget to show us some support with stars. Thank you for listening.